Welcome to the Desk of Gladiator. Desk of Gladiator.
Yep. It's America time. Happy President's Day, and welcome to Desk of Gladiator.
Hey everybody, it's a sample Sunday on the Desk of Gladiator where we take some time and look at samples. That's one of my jobs. I have many hats that I wear, some fuzzy, some with brims, some visors, but the most important hat I wear is sample tester. I get 5 to 10 samples a week. Sometimes new products that I've picked out or requested, sometimes upgrades, sometimes companies send us samples to check out their products. And so I like to spend some time every week going through these samples and seeing if this is something that we should carry. That's, me basically doing the stress test is what determines whether it makes it into the shop.
And that's why we call today Sample Sunday.
Yes. So we've got some exciting samples today, including arcade buttons, some cool USB cables. I'm going to start with spudgers. I got 2 spudger samples, and I actually got the idea for carrying these spudgers from Bunny. He linked to this really cool person who does like iPhone repairs, like really intense ones. And I'll turn this down. And they use this tool when they're... maybe I'll full screen this. They're using this tool here to carefully reach underneath the BGA as they heat it up to remove it. They're removing, I think, the RAM from an iPhone 6. So that tool, I was like, that's kind of cool. This is the UV curable mask, which, or maybe it's flux. Yeah, it's flux in a little syringe. And then there's also some UV curable mask that this person uses. So I wanted to start with the spudger, because I thought the spudger was pretty cool. So I got 2 spudgers, so let's check those out. I'm not going to do any BGA rework, but you can get a good feeling for whether this is a good tool by looking at it. I got 2 versions of these from one supplier. One is stainless steel, and one is just iron. So, I guess just like plain pot metal. So this is the
only live show that brings you the latest and greatest in spudger technology.
Yeah, I can feel this is like chromed. It's good. I have a magnet. I think these are both. Yeah, these are both magnetic. So it's not like one of them isn't. It'd be nice if they weren't magneticable, but that's what it is. And there's like this kind of flat round tip, and then a slightly a pointier one. So this is the iron version, and I think this is the stainless steel version. So let's extract this. Yeah, the stainless steel version, it seems a little sharper and a little less rough. It's really hard to tell the difference, honestly, but like if you kind of twist it, you can see this is a little bit smoother. I think the stainless steel is a little higher quality. It's also definitely thinner. So you can see how thick these are. Let me move this out of the way. So this is the stainless steel one, and this is the iron one. So you can see the stainless steel one is much thinner. So that's a pro. Kind of want it to be as skinny as possible. Yeah, again, this one, now I flipped it around. This is the stainless steel, and this is the iron one. So I think the iron one is, basic usage, and the stainless steel is probably like fancy usage. And I'm going to go with the stainless steel one. I think it's like $1 or $2 more, but I think it's worth it to have a really good, slim wedger spudger tool. And we have one in the store already right now that's from iFixit, which is okay, but it's not this style. This is kind of like a medical tool style. The one we have in the store is kind of a wide. I don't know if I have one here.
Yeah, as folks pointed out in the chat, we do have some of the iFixit tools. We don't have all of them. Any ones that we can actually resell, some of them they sell at a pretty close to cost price, so those are hard, but we do have some that we stock in the store, and of course, if there's something that Lady Ada likes, like
Yeah.
these spudgers,
I like this
we'll
one.
stock them.
I think I'm gonna probably carry, I'll probably order like 100 or 200 of these. I like these. They're kind of sharp. They're also pretty good for like spreading stuff. They've got like like a flat edge here, so you can like spread epoxies or paste with them. They feel like pretty good general purpose tools, and I like that you get like double design, and then there's this knurling, which is kind of a nice quality to it. So okay, spudger samples. I'm going to approve the stainless steel one. Comes in this like plastic thing. Okay, so this is spudger samples. First sample are done.
Okay, here's a question from one of the chats.
Yeah.
Once you figure out you like something like this, how long does it take for you to first, when you see it, you get it, to prove it, and then it's for sale in the Adafruit store?
Usually, if I just ask for standard service, I get my samples maybe 2 weeks after or 3 weeks after I request them. So I think this bunny tweet was, let me see where he tweeted. He tweeted in mid-January. So yeah, sometimes it takes up to a month. I think these were from a Chinese factory especially, so they took a little bit longer because it's Chinese New Year until now. A couple days ago, a couple weeks ago, and so there could have been a delay. And then usually once I approve the sample, it's also another like 2 to 3 weeks. I mean, I can expedite it. I can say, look, I want it hot. I want it expedited. And I could do that for everything, but I found that if you expedite everything, you kind of get nothing expedited. Like, I'd rather reserve my expedited needs for when I really need something. Like, hey, I ran out, or this is like really important. I get it immediately because I have a date that I have to hit. For stuff like this, it's like I have something coming in every week, and so unless it's something super important, like these spudgers, they're cool, but like there's nothing I'm waiting on for them, so I'll just get them standard turn.
Okay, so which one did you go with again? It was in the chat.
Stainless steel one.
Stainless steel.
A little bit more expensive. I usually go with the more expensive version, but not always. Sometimes I really can't tell the difference. But if there are two versions, I get one of each. You never know. Like, they might have different purposes. You might find, like, oh, the cheaper one is more flexible or something. Okay, next up, I've got this 4-pin terminal block. So this is a pretty simple sample. It's just a 3.5 millimeter terminal block, except usually, you just get these in twos. The only difference with these is they're black. They're from a new supplier, and they're like, oh, we'll provide them to you in black. And they're already connected, so you get 4 of them in a row. And that just means that they fit nicely into things like this feather wing design, which has a stereo audio output. So just make sure it fits. Is it the right size? You'd be surprised. Like, there can be variations in width or diameter or like thickness or this stuff. Oh, sorry. So this looks good to me. So I'll probably approve this. This is not a big deal sample. This is just like a new supplier of an existing SKU. So that happens. Okay, so that's good. Easy peasy, lemon squeezy. Okay, next up we're gonna go to the fun stuff. So I got these LED arcade buttons. So these are just like the arcade buttons that we stock in the shop, except they have an LED built in. So this is the black one, and then they have these terminals here that are used for the button. And then I'm not too worried about. This is a completely standard. These are the plug-in terminals for the buttons. But what's neat is that there's a separate PCB inside. These are a little bit more expensive, but they have a PCB inside, and then there's this connector. And luckily for me, I was actually just, because I was looking to see what cables I had to do these samples, this is actually the same exact connector that we use for our batteries. So I can actually just sort of plug this in. And then, so you get like kind of a cool blue look, and then this has a protective plastic on it. So it's kind of a nice blue-black. I'm into it. Kind of dig it. So then, for this one, I'm kind of curious of what's going on inside. So I'm going to try and, maybe I'll use my smudger. I got the smudger, so why not smudge with it? Let's see if I can get this opened. Maybe I'll get one spudger on that side.
I'm going to ask a question.
Yeah, what's up? I'm spudging.
Okay, so does Adafruit have a dedicated person for sourcing, or does Lady Ada do it all? I'll answer the second part of it. There isn't just one person at Adafruit. We're 100 people in New York City, and then we work with different people around the world. We have remote team members, we have other people we work with, but Lady Ada does a majority of it, but she is not the only one. Do you want to elaborate more, Lady Ada?
Yeah, I think I basically do the initial stuff. That this spudging is not so spudgy. Oh, there you go. That's the right way to do it. I do the initial samples, so like, getting that first sample in and approving it, and then I hand it off to the purchasing team, because when you do purchasing, like the sample is actually kind of like the easiest part. The challenging part is, like getting pricing, getting them shipped. Okay, hold on. This is annoying.
Well, I'll tell everybody.
Hold on, I'm
I'll
smudging.
tell everybody a little bit of my story.
Yeah. Okay. Hold on. I got it.
Okay, no stories for me.
No. 1 second.
No, that's fine.
Okay, so now I got this open after much effort. So you can see inside that, so this is the cap, and this is the switch. And then inside, you can kind of like, I don't know if I can, you can see inside, and I'll point with the spudger. So this is an LED over here. And then there's actually a resistor, so that's kind of good. And then there's another LED here. So there's 2 LEDs. And 2 resistors, and the resistor values are 1K. So that's actually kind of nice, which means you can give it, pretty much anything up to like 12 volts maybe into these LEDs without damaging it. So I just wanted to make sure that there was a resistor that went with the LED, and just checking out the quality of the PCB design, but I'm into it. All right, sorry, tell a story.
Oh, well, one of the things that I was going to say is watching how you work and watching kind of the collaborative nature that we have at Adafruit. So most often, if we see ourselves purchasing something or wanting a cable, or kind of imagining like, what if Adafruit was the only place in the world, could we have thousands of products where you could just walk over, anyone who works in the company could walk over, or of course someone who goes to adafruit.com could visit and kind of get everything they need. And so a lot of the kind of clever things that you see, it's like, oh, I could see that, I could see using that. It's because Lady Ada, myself, or a variety of other people said, oh, this is something useful. So that's why everything is highly curated, and if we have it in the store, it's something that's special. It's something we use behind the scenes here at all the video shows and all the things that you see at Adafruit. We use all the equipment and all the products, and so we're never kind of out. We always have a spare. And so I remember when you started the company, you wanted to have a place where you can get kind of everything.
I personally just wanted some of these things, and so like the tools, like I use these tools all the time, and so some of our most fun products or devices are things that I personally want. Like, I've built arcade cabinets, and I would have really liked to have LED backlit arcade buttons. So, being able to test this, I know kind of like, well, would I personally have wanted it? And it's a little biasy. I put in stuff that I personally like, or I think is pretty cool. But so far, most people agree with me, or a lot of people agree with me.
Yeah.
So that's great.
Oh, there was a question about that button.
Yeah, what about this button?
Okay, I'll go to the question. Why do those buttons always have so deep when the button doesn't have so much travel?
Usually because, well, this one isn't particularly deep, but usually they're a certain thickness, partially because this switch, they do have a bit of travel. There's a bunch of layers here. It doesn't really matter how thick they are, but they often have to go into 1/4-inch plywood. I think like the arcade machines themselves have pretty thick wood, and so they would be, or they might have variation in the size of wood, so they would be different sizes. Also, it gives them a good solid construction. This is considered a fairly slim arcade button. It's not that big. But I agree, it is a little bit bigger than it needs to be. On the other hand, for the LED backlight, it's kind of nice because it means there's plenty of space for diffusion. And I like how they use the acrylic for diffusion. So this is the black one. And then there's also a matching white one.
Okay, do you want to answer a couple random questions
Yeah, sure.
while we do this?
Yeah,
Okay.
here's a white one.
One of the questions from the chat is, Quick question. I'm wanting to start working with the Atmega 32U4 boards, but the only experience I have is with the AT85s. Where can I go for guidance with this?
It's the same chip as used in the Leonardo, so there's actually a lot of stuff available if you're interested in, like, well, what can I do with this chip? Check out, like, the Arduino Leonardo
Yeah, we have lots of
board and tutorials that go with it, and I think you'll find a lot of stuff. I mean, one nice thing about it is it does native USB and also has like a lot more pins and stuff compared to the tiny 85.
Yeah.
So this is a white button. So it's kind of nice because there's this you can remove this, so you could put like a sticker or something here. I think that could be kind of cool, right? And then it would show through,
That's
and
cool.
it would light up a little bit, not a lot, because this is pretty opaque.
Yeah.
And then also just looking again, okay, yeah, there's the 2 LEDs and 2 resistors, and the resistors are also 1K. So that's kind of nice.
Okay.
So I think that this is pretty good. I think the connector for the cable is like, well, it's a standard JST. It's a little unusual, but at least we can carry those cables.
We're making a arcade cabinet at the office, so we're going to be stress testing a lot of these. Here's an unrelated question.
Yeah.
I'll ask. Is it possible to stream video with Feather?
No, you need to use something like a Raspberry Pi. Even a Raspberry Pi is going to struggle. Video is very hard to stream.
Okay. And then a follow-up. This person wants to work with blank chips, that Atmega 32U4s.
Yeah.
They just have no idea how to wire it up for the 8 megahertz crystal.
Just connect the crystal from, like, I think X1 to X in, X out. You can also look at the Feather schematics and just copy those. Honestly, it's good enough. We have a bunch of dev boards in the store for the chip. Just look at the schematics, and whatever we do, at least it worked for us.
Yeah. Okay, what else you got?
Okay, so next up, so I got these bigger arcade buttons, and so then I also got these smaller ones. These are kind of the big stuff. These are kind of cuter, teeny ones. They're not as nice switches. Like, these are like really nice switches. These are okay, but they're smaller, and so there might be situations. These are not just for arcade games. They're also for control panels or music videos or whatever, or like you want to just control stuff. And this is a different style. This style is you really just drill a hole, and then you can be almost any thickness, and then you mount this in. And this has 2 contacts for the switch as normal, and then there's these other 2 contacts. So for that, I have some alligator clips connected up to a 3.3 volt power supply. And that's not that way, so maybe it's the other way. That's also not the way. Maybe. I hope I didn't burn it out. Is it connected to? Hold on. This is 3 volts, and this is ground.
Oh, I think it's time for a Sparky break.
I hope I didn't break it. Well, we'll find out. Give me 1 second, because it's going to be one of these pairs.
Sparky's going to show up. Sparky's waiting.
Oh yeah, maybe I broke it. All right, you want to show Sparky?
Take it away, Sparky.
Alright kids, here's the deal. Post up your projects on the internet. Don't worry about people complaining and saying, don't use Arduino. The worst thing that can happen is you'll see me as Sparky the Blue Smoke Monster, and that ain't so bad.
Okay, well this one works fine. I don't think I broke the other one. I mean, I guess it's possible.
It's okay.
It's okay.
Don't read the comments.
Don't read the comments. So this is, so I just connected alligator clips, and what's nice is it's a smaller button, but, and you can also see there's 2 LEDs because there's 2 bright spots. And it looks really bright on this overhead, but it's actually not, it's not that bright. I mean, it's a nice glow, but it's not crazy bright. And then let's take this apart. So this one's the green one. So likewise, I guess we spudjo here. These are kind of nice spudgers.
You use the tool to make the tool to use the tool.
Okay, so this one also has 2 LEDs. There's one here, and then there's only one resistor. And the LEDs are in parallel, which is okay. And the resistor is only 200 ohms. Okay, so we just gotta watch out for that. I don't think it's 102, I think it's 200. So that's the green one. So yeah, maybe I'll just tell people like, look, for these, they only have a, 200 ohm resistor. So best use, with 3.3 volts. So this is the green one.
Giving the smudger,
Smudger.
a run for its money.
This spudger, well look, I got it, if it broke halfway through it.
A run for its smudgy, yeah.
Okay, so this one's pretty nice. I kind of like this one. Green's good. So let's put that away. Let's try.
Did you say green is good?
Green?
Oh, green, sorry. Okay.
Green is good. And then we have yellow. I'm looking for this red one. I don't know. I don't think I busted it. I am only powering it from 3.3 volts, which, as long as there is a resistor, should be fine.
Here's a question from the chat. Why wouldn't
Yeah.
they use a more resistive resistor? Wouldn't it really be the same price?
Yeah, they should. I don't know. I mean, I might, when I order these, if I order like more than 250 or 100, sometimes you can get them to do custom stuff, but like, the problem is I'm not going to open up every arcade button to check. Well, interesting. Yeah, this isn't working. Neither this one nor that one, which is very suspicious. Hold on, I'm going to open this up. Because like, why would the green one work, but then the yellow one doesn't? Like even 200 ohms, I mean, it's not a lot, but it's not going to break at 3.3 volts.
It's time to check this out.
It's kind of time to spudge. This is a nice tool.
I need any more Sparky videos, so if you blow it up,
You can just play the other one again.
I guess.
I just don't want to spudge myself.
Want me to take a crack on it?
No, I've got multiple tools I can use. There you go. Okay, so this one. Oh, weird. Okay, so this is a different design. So remember that other one was it had the 2 LEDs in parallel. This one has them in series. Is it time for the whiteboard?
Yeah, man.
Okay.
I gotta get it. I'll be right back.
Yeah.
Going
Interesting.
to the whiteboard room.
Yeah. Maybe I'll open up this one to show it. Interesting design decisions. Thank you for the kind whiteboarding. Okay. So here's what's going on, which is why I was like, why isn't this working? So for the green one, they've got, the plus and then 2 LEDs. To a 200 ohm resistor. And the reason they did that is I think that they're intending this to be used strictly by 5 volt power. So when you would give it 5 volts here, green LEDs, especially the bright green ones, are always going to be like 3.4 volt drop. So this is going to be 3.4. And I'll do my quick math. 5 minus 3.4 is 1.6 divided by 200 is, what, 80 milliamps? Hold on. I don't want to get this wrong.
Just to give you a heads up, people want NeoPixel arcade buttons.
I know they do.
I know.
We
I
had
know,
a tutorial about
We're
it.
working on it.
1.6 divided by 200. Sorry, 8 million. Yeah, see. So this is 8 milliamps total at 5 volts, and which means it's 4 milliamps per. Because it gets split in 2. Now it's not like 100% perfectly divided by 2, but it's pretty much 4 milliamps per LED, which is bright enough. And I guess the standard is 5 volts. So what they did for the yellow design and the red design is, I wish they'd been consistent, but I guess, I don't know why, but they decided not to. They decided to do it instead where you have the 2 LEDs in order. And then the resistor is 200. And the reason they can do that is for red and yellow, the LEDs are actually made out of a slightly different material. And so these are about 2.1 volt each. So this is, probably 5 or 6 volts. 5 minus 2.1 minus 2.1 is 0.8 volts divided by 200. Again, 4 milliamps through both of them. So it's kind of funny. The math works out. So it's like because of the division, these end up to be about the same amount as these. So, interesting. It's not a big deal as long as you just realize that you can power this off of 3.3 volts because these will turn on slightly, but you really need to have at least 4 volts to turn these on at all. And so that's why it worked even from 3.3 volts and it didn't work at all.
Okay, question in the chat. Where do you get green LEDs with 3 volt forward voltage? I thought only blue was 3, the others were 2.
There's 2 kinds of green LEDs. You can get what's called pure green, and I think it's I think these are GaN. I think that's the gallium nitride. I don't know. I think they're called like GaN LEDs. There's pure green, and then there's yellow green. If you get yellow green LEDs, which is probably what's used in here, they're a little bit more like lemony colored. Pure green has a really like deep blue green color, and those are going to be 3.4 volts rather than 2.2, which is what you get for red, yellow, and yellow green.
Okay, one comment. I think the material is arsenide, maybe. And then the question in the chat was, for the other, you need a level shifter. Is that correct?
No, you don't need a level shifter. It's more like you just have to power it from 5 volts. So now if I just change my alligator clips, so I had this connected to 3.3 volts on my Feather, but if I connect it to USB instead, and now I try to power it.
Gallium nitride.
Gallium nitride, yeah. I don't remember if that's the pure green or not. I mean, you'll definitely know the difference. So this is now with 5 volts, it does light up. So that's the secret. You just have to give them 5 volts. You can't power these off of 3.3. Just. Okay. I kind of get why, but it would have been easier for them, I think. Like, if I was designing this, I would have just designed it with one PCB for both and just changed the resistor value. I don't know. So this is yellow. Looks kind of nice.
That is nice.
Yeah, 5 volts.
Okay.
Not too bright.
Side quest question.
Side quest.
If someone's looking to do audio and video stuff, is the Pi Zero capable of doing it?
Pi Zero might be able to. Pi 3 is going to be more capable. And this is the pure green. You can really tell pure green when you look at it compared to yellow green. Pure green has this, it's a very like emeraldy color to it. Yellow green, it has more of like again, it's a yellow green. You'll know when you have them next to each other. The pure green, I think, looks better. It has like a really beautiful like bluegrass color. But the voltage is higher, and they're going to be more expensive. The process to make the LEDs is more expensive. Okay, so this was green. So let's put the green back. Hold on. Green goes back. Each of these sample bags is labeled with an ID number, so I want to keep them in the right bag so that I can refer to them later. So I did the yellow. Yellow works fine. But what's really important about testing these things is like, as you see, as I'm testing it, I'm like, oh, why is this working? Oh, okay, now I understand. You know, if you don't put the experience of actually testing each one, you won't know what to write in the copy. So now I remember this, so when we get these in the store, I'm going to remember to write in the text copy for the red and yellow, hey, you absolutely need to use 5 volts to power these. You can't use 3.3 volts. It won't light up at all. And that will avoid the problem of, you know, in 2 weeks afterwards, somebody's like, hey, I'm trying to use these with my 3.3 volt microcontroller and they're not lighting up. Why? That's why.
Okay, do you have any suggestions for a good illuminated button for a pedal?
We have some good buttons in the store. I mean, they're not, the buttons themselves, it's going to be really hard to find a button that can handle like a foot switch type pedal. But we have many LED like panel mount LEDs or like LEDs that are
Okay.
that embed into switches that are smaller. These are just kind of nice because they're like arcade style.
Do you have any idea of what the color temperature of the green button is?
You wouldn't get a color temperature. You would get the nanometer wavelength. All pure green LEDs are pretty much the same wavelength. So just like go to DigiKey or something, type in pure green LED, and look at the wavelength, and it's whatever that is. I don't know it off the top of my head. Okay, so this is red. So red's now lighting up. So there's a little bit of a thing where the center is not going to be. There's a little darker spot. That's the actuator. Not much you can do about it. I think it's okay. Just I think as long as we tell people, hey, there's going to be a little bit of a spot in the center. Okay, so it's red. And then here's white. I'm almost done.
Yeah.
Fucking through these samples. White, nice. Kind of a nice color. Okay, so that's all of those. I think these are like 16 millimeter buttons or something. There's some blue for them. Oh wait,
Okay.
I have one more. I have a blue one.
And I'll mention this. So one of the things that we're doing is we're putting a camera on what Lady Ada does on a regular basis. So this is actually how the stuff goes in the store. If you ever wonder why everything works and why the copy's accurate and why the photos show what it actually does, this is why. And then another
Yep,
thing is,
this is what I do.
Michael has a question, comment, export more stuff to the UK. You can go to adafruit.com/distributors, and any distributor in the UK, you can ask them to stock a variety of rare things. Also, companies like DigiKey, Mauser, Arrow, Avnet, who else stocks our stuff that's like a global supplier? Element 14.
We also have tons
Newark.
of British
Yeah.
distributors, yeah. Okay, so now last step of this button set is blue. So when I get from a supplier, if they have multiple colors, I'll get one of each color. And so the blue is also good. Blue is also going to be one of the ones that's 3.4 volt. And then from the first button supplier, I also got some of the smaller buttons. These are, again, skinny buttons. These are kind of a nice actuation. The only problem is, like, the connector they pick is, like, really small. It's, I think, 0.05 inch pitch. So the only way, really, that I know how to connect to it is I'm just going to, like, hold some wires up to it and just hope that it works out. It might annoy my feather a little bit, but let's see. So
Yeah.
this is very unelegant.
Popular request. Anything NeoPixel inside of a button.
Yeah, they're just not really available.
We'll get there, kids. Don't worry about it.
Yeah, it's just a process. Okay, so how am I gonna get this going? Maybe like this. Wrong
How did the
part.
low voltage standard become 3.3 and not 3 or 3.5? That's an interesting question.
So this is the blue. So it's definitely, it has to be higher than 2.5. I think it's 3.3 is 0.7 times 5. Yeah, I think they wanted to make it like about 2/3 of the way towards, it's 2/3 of the way towards 5. And so if you use 5 volt logic, it's, and you get to the high level, it's clearly higher than 1/2. Why they actually picked 3.3, I don't think there's like a specific reason other than they probably did just say like, well, let's just do 2/3 of 5. And then 1.8 is what, 5? Is like about 1/3 of 5. 1.8 volts is a little tougher. And then, it isn't actually just 3.3. There's a lot of 2.8 volt electronics too, which is really annoying because it's like, it's not 3.3 volt either. I don't know if there's like a good etymological reason
Yeah.
for 3.3.
Someone pointed out if you want to see an excellent tutorial on 3D printed buttons that use NeoPixel, Noah and Pedro have one at
They do.
learn.adafruit.com.
They did. They made a really good one. So check that out. It's like, I think people want NeoPixel buttons, but the majority of people who do arcade stuff don't. So, because they don't know about it or something. So that's why I would say building your own is a good place to start. That's not.
Oh, Chris Young says he thought it was 3.3 because CMOS offerings at that voltage.
Right, but like, why did they pick that voltage?
Yeah.
Like they had, you process the CMOS to be that voltage, but why they process it that voltage? Like somebody picked it. Like it was a decision. Okay, so this is a smaller button. I mean, it's pretty, but this connector is really annoying. So I might pass on these just because of the annoying connector issue. Like if I'm gonna carry buttons that are about that small, I'd rather carry these.
Yeah.
They're a little bit longer. Well, they're not crazy longer, but they're much easier to use than these. Although these have like better action, but I think the
Rob in the
smaller
chat
buttons.
says because the JDEC chose the standard to be 3.3, the JEDEC.
Right, but why did they choose it?
Yeah, it might be because we're in this universe where the electrons spin this way. It might be
No,
just
no,
like,
it's an arbitrary decision.
Yeah.
It's an arbitrary. Somebody decided it for a reason.
Hmm.
Yeah, there was somebody who said the JEDEC standard is 3.3, and then the people who made CMOS logic are like, hey, we're going to make the standard 3.3, and then all the people who
That's a
made
good question.
microcontrollers were like, okay, we're going to pick 3.3. They all picked it because somebody picked it. It's like there's one person who picked
Yeah.
it because they could have picked 3.6 volts,
If anyone
which would have
knows-
been 0.7 times.
If anyone knows like the real reason, not in addition to someone who chose it,
Yeah. There
let
has
us
to be
know.
like the initial choosing this. Okay, so
Micah says something to do with TTL compatibility, maybe.
yeah, but like TTL is it turns on at 0.7 volts.
This is a mystery of mysteries.
There is some reason.
Yeah.
There is some reason out there. Like, it absolutely have to be greater than half of 5 volts. Absolutely. Because then you could have at least 3 volt signals read from 5 volt signals. Like,
Yeah.
that I no question.
I'm going to blame Sun Microsystems.
Yeah. SGI and Sun, everyone loves blaming them. Solaris' fault? Scott McNeely? Okay, this is the
Bill Joy.
wrong way. Yeah, I do not like this connector at all. I mean, even if I had the connector, I wouldn't
Yeah.
like it. It would just get snagged. But I thought I would just light this up. Okay, so this is the one, the white version. It's pretty, but I don't know. I think people are gonna just break these connectors because it's not a standard that we stock. It's gonna be a problem. So I'm gonna probably pass on these 2 buttons. Okay.
Yeah. So on Twitch, so they used our products in a costume from TwitchCon's cosplay contest. Really enjoyed using our stuff. Thank you.
Yay!
That is one of the many places and groups of people that a lot of us at Adafruit hang out with. So cosplaying, and we have a lot of wearables specifically for, the idea that you would be able to make any type of character that has anything that lights up or makes sound. It's one of the goals.
Okay, so last but not least, I only have one more sample to go, and this is weird ass cable. So this weird ass cable has an LCD in it. So
I should have called the title of this show Weird Ass Cables.
you should have,
Yeah,
but it's Sample Sunday
I
instead.
know.
Okay, so let me plug this in. And then, so I have an extension cable here. So this weird ass cable, well, I wanted to get a couple different cables that had switches or like, they were the cable and they had power info on it. So this one will tell you the voltage and current. So let me plug in my Raspberry Pi. Let's see what happens here.
Yeah, this is a power monitoring cable, and it's freaky weird.
Okay.
We don't know what it does yet.
Yeah, hold on. I got on this like. It's very unhappy with the backlight.
Yeah. You might want to bring it closer to the screen and then focus it.
Dude,
I know that
I'm
sounds.
trying
No, see this.
each option.
And then you could lock it once you get it close.
Once I get it, but yeah, that's kind
is-
of as good as it's gonna
What is
get.
it, like 4, 2?
So it's drawing. So the voltage is 4.8, which makes sense because I have like a huge extension cable plugged into my hub, and then it says so 4.8 volts and 0.26 amps, and then I don't know what min stands for. Kind of weird. Look at the instructions, but yeah, I mean it tells you it's drawing about a quarter of an amp. So overall, the idea of this cable is cool. I like the idea. The problem is that I think that oftentimes, if you're trying to read the current and voltage draw, I don't know if I want it at the USB plug. I would rather have it later on in the cable.
Yeah.
So I got a couple different samples. This is just one of the samples, but it does work.
Okay.
Oh, maybe minutes is actually how many minutes it's been plugged in.
Yeah, probably.
Maybe, like you can see how long it's been charging.
We'll wait a few minutes and see. Because
Okay, so it's one.
maybe you'd want to see how much current it draws while it's charging something. Okay, question from the chat.
Name's weird. Yeah.
Ready?
Yeah.
Question from
I hope it's a Spudger question.
from last night's show.
Yeah.
You had something with the CMD circuit playground that would likely have IR transmitter receiver. Is that for proximity or for remote control?
Oh yeah, both. I can show that off because I finished routing that today.
Oh, okay. Yeah, in the chat someone said both, but yeah. You want to show it off?
Yeah, because I was
Okay.
I actually
This is gonna be cool. By the way, we're getting so close to being complete.
I'm close to being done.
Yeah,
But
alright.
it's important to do it right.
To EagleCAD.
So I'm an Eagle Cat. So I have the silk screen because I was looking at how much the silk screen's changing. It's going to change a bit. But, so the temperature sensor is still over here. The photocell, the light sensor's over here. I still have the left and right buttons, but as you can see, I kind of scooched them. So like the triangle used to be in the center. So I scooched the button up a little bit because I got rid of those resistor packs. That's why I was doing the capacitive touch, the Q-touch stuff the last couple weeks. And then what I did is I removed the other resistor pack that was here. And one I2C resistor is here, and then one I kind of scooted over here. And then I freed up a lot of space here, so I put the RC filter that goes into the Class D amplifier. Let's see, hold on, Class D amplifier. So this is the RC. There's an RC filter that goes into this op amp here. So that's done. And then I have this bigger speaker, and then this D4 and D5, this silk screen is going to go away because it's clearly it's overlapping. I'll just move it elsewhere. But right now I have an IR transmitter, and it's connected through an NPN transistor with a base resistor. And then over here I have an IR receiver, and it's connected to a Vishay IR reader. I actually thought, like, oh, can you maybe do raw IR reads directly from a microcontroller pin, an analog pin, and like filter? It turns out that there's a lot of like automatic gain control that you need to do, and so you need to have the biasing for this diode happen automatically. And it's like, I mean, you can get basic signal working using just a microcontroller, but for another 15 cents, this is worth it. It does like a lot of the nice filtering for you, and like automatically biases your diode based on the DC offset, so it'll pump more current into it if it needs to get more gain. So that's kind of nice. And then this is that PDM microphone. So the analog section for that PDM microphone got removed because it's now digital only. And then I have an IR receiver section here and an IR transmitter. Some of it's over here and some of it's over here. And what's nice is that they're on opposite sides. And what I can do is I can probably, you can just pulse 38 kilohertz out of here and it'll get picked up by this thing. And so you can do a basic, is there something in front of me sensor? And I think I might be able to eventually connect an analog pin to this line. And then even though this does some automatic gain control, maybe if I do really short pulses, like before the AGC kicks in, I can do the DC offset reading, and it might be able to tell me how close the hand is, like if my hand is like right over it. And then this is the schematic section.
Okay, can you let us know what part number you're using for the IR receiving?
I'm using the VSOP 383.
VSOP 383.
IR preamp.
Yeah, and then
just you put an IR diode on it. You just want a little bit of filtering on the power supply, and it gives you the pulse output without the 38 kilohertz carrier. So it kind of does all that for you. And then over here I have an IR transmitter connected to just a simple, it's gonna be an NPN with a resistor. And what's interesting is you're like, well, there's no resistor here. Like, why don't you have a resistor? What happens is that these IR LEDs, this is from what I learned from the TV Gone, you drive them at about 1 amp peak. Like, they pulse extremely powerfully. Like, but you can only pulse them, like very short blips. But as long as you're doing that little blip, because you're just sending an IR signal, you can drive them as hard as you want. The die can handle it. It can handle an amp or more, sometimes 2 or 3 amps. And so what happens is this saturates. This diode ends up being about 2 volts, and then this saturates also at about like 2 or 3 volts. So you don't need a resistor here, as long as you have a resistor here to limit the base current from the microcontroller pin. That's the only thing you need to worry about. This is going to saturate way before. This will limit way before this goes above 1 amp. So if you look at the TVB Gone, I did the same thing. In fact, I used another transistor to drive this transistor, kind of like a Darlington-y style, just because most microcontrollers couldn't give the TVB Gone enough current for all 4 LEDs. What's that?
Okay, a couple random questions, then we'll get out of here. Can you upload code via an IDE to the Bluetooth 32U Feather over Bluetooth? The person tried, but they couldn't get it to work over.
You can't upload code to it. It won't reprogram the chip, and that's kind of by design. The NRF52 Feather you could, but that code would have to be for the Nordic chip.
Okay.
So the over-the-air only works for the Nordic chip, doesn't work for the 32.4 chip. So you program your code with the Arduino IDE, and then you just use the Bluetooth for communication.
Okay. Shout out to Chris Young. He's thinking about making the IR library support the M0.
I will absolutely make sure that it works with this, because I was thinking about what kind of projects could you show off that would allow people to use like the capacitive touch or like these really big pads, so they wouldn't even need to solder. They could maybe use alligator clips to create their own switches. And like you can get like these arcade buttons that we're using, which I just had. Like these arcade buttons might be good for people to press, and then the connectors on the bottom are like nice and big, so they might be able to use alligator clips or just crib connectors and connect to this and use that to send IR signal or receive IR signal, and then do something with it. You could, because it has receive and transmit, you can also do decoding. So you could have you have one IR transmitter that then can control multiple devices, because I remember you had a setup that did that. So I'm kind of thinking about like, not only would this be cool for, fun like projects, but like it could be really good for accessibility, where you can use IR to control stuff around your house, and then alligator clip to the circuit playground.
Yeah.
And then it'll be programmable through Python. So it'll be really easy. We can have example code, and then you can maybe have it like learn a remote control signal, so you record and play back. So trying to think of some of these ideas for how we can use IR as like a way to do a lot of different kind of communication, not just TVB Gone style projects, although TVB Gone style projects are pretty cool.
One of the things that we noticed,
Spudge.
We certainly didn't set out to do this, but assistive technology is one of the things that we're really happy to see so many people doing stuff with it. Completely random, in the Twitch chat, someone won the TwitchCon contest. They made a fake NeoPixel eye because they happened to be missing their left eye, and they just wanted to say thanks.
That's so cool.
They just wanted to say thanks because they used the Adafruit stuff. And that's even more of a decorative use, but I'm noticing more and more people are using, especially with Bluetooth and being able to control devices. Anyone who's really interested, check out Chris Young, who's on our show and tell often, and he has a lot of neat stuff.
Or maybe like, we have foot switches, because that could be good for some people. I know there's people who want to be able to control stuff around the house, and they can't use controllers in their contacts, and they say, the foot switches that we carry are really good because they're really durable, and you can hit them with your shoulder, or you can hit them with your foot or with your knee, because they give a good clicky, but they're not too hard to press.
Yeah.
So like a lot of different switches, and so I like the idea of we will eventually have a Bluetooth version of this. Not ready yet. I'm waiting for the next generation of Nordic chip to be able to. I might as well just wait. 'Cause it's going to be a couple more months. While I'm finishing this up. But I like this pattern. This is kind of what I wanted with the original Circuit Playground. I wanted to have IR receive and transmit, because I think that gives it interactivity. And then you can have them communicate with each other, which I think is pretty cool.
Yeah, we'll have Wi-Fi. We'll have Wi-Fi one day, don't worry.
Yeah, we'll have a lot of stuff. One of the things I was thinking of is, you could alligator clip or screw something on to the pads, because I have I squared C and RX and TX UART available on these pads. So using just like a screwdriver, you could screw together a board maybe on the back that would give it Bluetooth or Wi-Fi capabilities. So this is some of the things we're thinking about. But I want to be able to do it when you have CircuitPython able to use it, and this M0 processor. You need use a 3240. Just like it's actually like just runs out of space.
Well, the other thing that I like is by the time we get to this, we'll have a more powerful chip, and you won't be stuck with just using the Arduino IDE. You'll be able to use Python, which has way more people that will be able to use it, so you'll have more people making things.
Yeah.
So it's actually all going hand in hand.
Spudgy.
All right.
So that's the latest version. I'm almost 100% done with the Circuit Playground. I just wanted to maybe add one more pin for the IR proximity sensing. I know you can do it without doing an analog read of the DC voltage, but I think if I can, I might be able to do like actual proximity, like the closer you get, the higher the signal. So I'm going to try that, and so I'm going to find a pin to route, and then I might also bring the analog 0 pin out because it's a pretty handy pin. And if I can do capacitive touch while it's connected to that Class D amplifier, I don't know if it would interfere. But if it doesn't interfere, if I can somehow get Q-Touch to work as a capacitive touch when it's not being in like Class D audio mode, I'd like to have that analog 0 pin be an output. So that's what I'm thinking.
That's a show.
When I'm not spudging.
I'm gonna go to this photo real quick. This is what this was sent in just right now. This is that costume that has. This is a person inside of it. Yeah, that's a person inside the costume, and they have a NeoPixel as their eye because they're missing their left eye.
Yeah.
This is so cool. Thank you so much.
Hardcore.
This is intense.
That's some serious. Is that Warbler? You think? Looks like it.
There's lions.
I don't know.
I don't
Yeah,
know.
it's like a lion chest.
Yeah.
Scary.
Okay. So that's the Descaladiated.
Okay. Thank you for spudging with us.
Yeah.
As always, Descaladiated will try to stream again maybe this week, but if we don't, well, you'll always be able to see us on Wednesday.
All right, thanks, Hoku Props in the chat and
Nice.
Twitch, and thank you everyone. We're here
Spudge
all week. Support open source hardware and a company like Adafruit by going to adafruit.com and purchasing some electronics. That's how we pay the bills. And
We'll have these in the store. You'll be able to get them.
a little bit of a logistic notes for those paying attention to our site. We have these little banners on it.
Yeah, you want to go to the store?
Well, we don't ship postal until Tuesday because Monday is President's Day.
Okay, so you want to go?
Yeah, so if you order something and it's USPS, it won't ship out till Tuesday.
Okay, if you go to the screen, it'll be really big.
Yep.
Here's your warning.
Yeah.
Yeah, it's a little bit too big.
Okay.
Sorry. Whoa.
All right, well, that's it, Lady Ada.
Hold on. There you go.
Okay.
Okay.
All right.
Maybe a little bit bigger.
Thanks, everybody.
Okay. Tuesday for USPS. UPS, it'll ship tomorrow.
Yeah. All right.
Later, Pups.
Make often, make frequently, make good, make electronics, make with oscilloscopes,
Say goodnight, silly.
frequently,